The law of sines is used to find missing side lengths and angle measurements in a triangle that's not necessarily a right triangle. If you look at number 1 and number 2, you'll see that there are no right angles in here. And it basically is this. And this will all make sense in just a minute, but let me point out a couple things real quick. Notice that capital A is across from little a. Capital letters, as you know, are corner points, vertices, and small letters denote the length of a side that is opposite the capital letter. So, in this situation, in number 1, we need to find the one that's labeled, and in this case, X is labeled. Well, for what it matters, X is really little a because it's across from big A. So here's what we know. We know big B, angle B, is 17 degrees, and we know that little b is 10. We know big A, angle A, is 43, and we know that we're looking for little a. So let's get a little more light on here. And that created a glare, didn't it? Oh, but it looks better. Here we go. So what we're going to do is set up a proportion, and we're going to use the first piece of this, where the sine of big A over little a equals sine of big B over little b. For what it matters, you could also flip this entire thing upside down. Same thing. You'll see it that way in some textbooks or on some websites. Anyway, sine of capital A divided by little a, which you could call A, you could call X, doesn't matter. I'm going to call it X because that's what it originally was, equals sine of big B over little b, and then we can simply cross multiply. Now, before we get too crazy with it, let's make sure we're in degrees. Yep, we are, so we're good to go there. Let's just go ahead and cross multiply without actually doing any computation. So X times sine 10 is really just X sine, sine 17. X sine 17, and then 10 times sine of 43 is just 10 sine 43. Wow, how amazing that is. Now we need to divide by the sine of 17. I want to put some degree symbols in here because it's driving me crazy without them. And then we will divide by sine of 17, and those, of course, will divide out. And we are left with whatever we get when we divide this, and we'll type that in our calculator. So 10 multiplied by the sine of 43 divided by sine of 17, make sure you close your parentheses appropriately, and we have a side length to 2 decimal places of 2333, and what is that? Feet. There we go. It is in feet. That's it right there. So there's number 1. All you have to do is match up angles with the side that's across from it. In order to use the law of sines, and this will be different than the law of cosines, which you will be introduced to later in this lesson, around about the time you get to about this page right here, right there. But this is different than law of cosines for this very reason. If you have an angle and the side across from it, you can use the law of sines. There's a slight exception to that, but we won't go there quite right yet. So, quite right. I'm not sure if that's really grammatically correct. Anyway, if you know, for example, in this case, you knew big B and little b, so perfectly legal to use the law of sines. If we look at number 2, you'll realize that we're actually not able to use the law of sines yet. Here's why. I know big A, but I don't know little a, also known as X. I know big B, but I don't know, I know big B and I do know little b. I was mistaken just a second ago and I said we couldn't use it first thing. Sorry, my bad. That was slightly confusing. Let me retract what I said. We can use the law of sines and we can do it first. Here was what I was thinking though. Sometimes in order to use the law of sines, and I didn't look ahead when I said what I said, but sometimes in order to use the law of sines, we would need to do some magical math to find that third angle first. For example, if we knew this angle right here, but we didn't know that one, then we could do our little fantastic thing we do where we go 180 minus 45 minus 63, and it'll give us that third angle. In this case, we don't have to have the third angle to start. I could go ahead and set it up. You know what? I'm going to go ahead and finish this. This is theta, also known as big C, and here we go. We'll type that in the calculator. I was going to do that in my head, but you'd be here all night. 72. Sorry, I just don't have the mental capacity to do that in my head right now. 72-degree angle right there. So I'm going to write down what we do know and what we are looking for. I'll write it in red. So theta is 72 degrees. All right, wonderful. Let's also find y and x. So, as I said, we could have started this with a law of sines. But anytime you start with a law of sines, you have to know at least two things. Big letter and little letter across from it. So I know B and little b. So the sine of big B over little b. And then at this point, it doesn't really matter. You could find x or y. I'm going to go ahead and find x. If you're in the mood to find y, you could, knowing that this is 72 degrees. I'm going to find x instead, using big A and little a, also known as x. So sine of 45 over x. Let's cross multiply. While I'm cross multiplying, I'm going to ramble a little bit and say some stuff I've already said. Again, keep in mind that you will use the law of sines two times. Two particular things I'm thinking of. If it's not a right triangle, although actually that could work, but generally we don't. If it's not a right triangle, and also if you know a big letter and a little letter that are across from each other. You know an angle and the side that is opposite that angle. So we can mark those out, and x equals whatever that is. Let's find out really quickly. 10 sine 45 divided by sine 63. 7.94, what is that? Feet. Alright, there we go. So we know that one. I'll just put a little red box around it so we know that that's one of our final answers. And we will find one more thing. We're looking for y. So therefore, when we're looking for y, c, lowercase c, if we're looking for little c, we better use big C in the process. So let's do it. You can use anything you know at this point. You can use both of these or both of these. I'm going to use these because if you use this, you're going to be using a rounded off value. So let's go with this one. So sine of big B over 10 equals sine of big C over y, or little c, depending on your perspective there. We'll do our same thing. These get redundant after a while, so let's just keep going. 10 sine 72, y sine 63. We'll divide by the sine of 63. We divide by sine of 63 here, and we cancel those out, and we have 10 sine 72 divided by sine 63. Whoops. There we go. Y equals 10.67 feet. We have found everything that was missing in this triangle. There we go. There's number 1 and 2.